Here's the equation: the square root of 3 times cosine of theta times tangent of theta minus cosine of theta is equal to 0. Let's go ahead and solve it together. Notice how there are two terms on the left side of the equation, and that they share this GCF or greatest common factor of cosine of theta. Factoring out cosine of theta from both of these terms, we can rewrite this equation as cosine of theta times the quantity of the square root of 3 times tangent of theta minus 1 is equal to 0. Now that we've factored the left side of the equation, we have to see how we can get the left side to equal 0 like the right side. In order for the left side of this equation to equal 0, because we're multiplying this cosine of theta by this root 3 times tangent of theta minus 1, that as long as one of these two pieces is equal to 0, then the left side of the equation is going to equal 0 just like the right side. So let's write two separate equations here. For one equation, we're going to set cosine of theta equal to 0, and for the second equation, we'll set this root 3 times tangent of theta minus 1 also equal to 0. So for our first equation, we have cosine of theta is equal to 0, and for our second equation, we have root 3 times tangent of theta minus 1 is equal to 0. For the equation on the left, if we take arc cosine of both sides, we'll find that theta is equal to arc cosine of 0, and for the equation on the right, we have to do a little bit more work here. To isolate the trig function, we'll start by adding 1 to both sides of the equation. And when we do that, we're going to get root 3 times tangent of theta is equal to 1. And then if we go ahead and divide both sides by the square root of 3, we'll find that tangent of theta is equal to 1 over root 3. And remember that we can rationalize the denominator by multiplying this by root 3 over root 3. So in an alternate form, we can also say that tangent of theta is equal to root 3 over 3. Finally, taking the inverse tangent of both sides of the equation, we can write that theta is equal to the inverse tangent of root 3 over 3. So in both situations, we've isolated our theta, so now we just have to take a look at our special right triangles and our unit circle to determine which angle measures help us get these ratios. Let's give it a try. Let's see if we can first find out when cosine of theta has a ratio of 0. Looking at the unit circle here, and also trying to remember the ratio for cosine of theta. So remember, cosine of theta is going to be the adjacent side divided by the hypotenuse side. That's going to be the ratio for the triangle, but also we can also think about that as cosine of theta equaling the x-coordinate over the radius, or x over r. Now remember that r, or the radius, is always going to equal 1, so really cosine of theta is something that we can simplify down to into saying it's just the x-coordinate in the unit circle. And so the only two locations on the unit circle where the x-coordinate is equal to 0 are going to be these two locations. So when cosine of theta is equal to 0, theta must equal 90 degrees or must equal 270 degrees. Now, it's important to note that while we do have 90 degrees, that's located right over here, that when we swing another 180 degrees, that's where the 270 degrees comes into play as well. And if you keep jumping in these 180 degree increments, you keep ending up in the same locations as these two angle measures that we already have of 90 and 270. And so there are infinitely many more angle measures that'll still get us cosine of theta equaling 0. As long as we keep adding these multiples of 180 or plus 180n or 180k, whatever variable you'd like to use, then we're going to keep getting angle measures that will continue to get us this value of 0 when cosine of theta is equal to 0. And if you're not completely sure about this, you can totally check this on a calculator and you'll find that cosine of 90 degrees is equal to 0, cosine of 270 degrees is equal to 0, and cosine of angles that are multiples of 180 degrees more than 270 are always going to get you 0. In radians, we can go ahead and write our answer as theta is equal to pi over 2, because that's the same thing as 90 degrees, plus pi n, or multiples of 180 more than 90 degrees. Let's go ahead and box that for now. Now, just to get a little bit more space, let's clear out this, and let's go ahead and move this up. Now it's time to find out tangent of what angle measure gets this positive root 3 over 3. So looking at the special 30, 60, 90 triangle, I want to look at this one just because I know it has a root 3 as one of the side lengths in its ratio. So the shortest side is always going to be 1, the longest side is always going to be 2, and the medium side is going to be the square root of 3. Now if we go ahead and take tangent of this 30 degrees, that's going to be the opposite over the adjacent, or the y value over the x value. That's going to get this 1 over root 3. So if we know that tangent of theta is equal to 1 over root 3, and we can rationalize the denominator by multiplying it by root 3 over root 3, then we can also find that tangent of theta is also equal to this root 3 over 3 if we have it in rationalized form. Since this positive root 3 over 3 is exactly what we're looking for, this is good news for us. Knowing that tangent of 30 degrees is equal to root 3 over 3 is super important because now we know where we can draw our reference triangles. We know we can draw one of them in quadrant 1 just because all the trig functions are going to be positive here in quadrant 1. And we know we can draw another reference triangle over here in quadrant 3 just because tangent's also positive in quadrant 3. These are the two triangles we're going to take a look at. And make sure you don't accidentally go ahead and draw triangles over in quadrant 2 and 4 just because you're going to get negative ratios because tangent is negative in quadrants 2 and 4. In quadrants 2 and 4, you would have the ratios of negative root 3 over 3 instead of the ratio of positive root 3 over 3. In quadrant 1, we have a positive x value of root 3 and a positive y value of 1. And in quadrant 3, we have a negative x value of negative root 3 and a negative y value of negative 1. Now remember, the tangent ratio is going to be y over x, so it's going to be positive 1 over positive root 3, which is going to be a positive 1 over root 3, or root 3 over 3. And when we're looking in quadrant 3, it's going to be y over x again, so it's going to be negative 1 over negative root 3, but that's just going to end up being a positive 1 over root 3, or positive root 3 over 3 again. And so one of our angle measures here is going to be 30 degrees, so I'm going to go ahead and write that down over here and say theta is equal to 30 degrees. And another one we're going to have is if we go ahead and start from 0 here and we go all the way until we get to this 30-degree reference angle in quadrant 3, that's 30 degrees past 180, and so 180 plus 30 is going to be 210 degrees. Don't forget, if we keep on adding 180 degrees, we're going to get back to this 30-degree reference angle in quadrant 1 again, except it's going to be 180 more, so that's going to be at 390 degrees. And we can go ahead and keep adding 180, and we can keep doing this forever and ever because we're going to keep ending up in the same locations. So as like we did earlier, then we can also say that as long as you keep adding multiples of 180 onto these, or 180 times n or k, whatever constant you're using, we're going to end up in the same location, and there are infinite number of angles that'll get you the same ratio. So just like earlier, if you want to test this on a calculator just to make sure, you'll find that tangent of 30 is equal to root 3 over 3, and tangent of 210 is also equal to root 3 over 3. And these are 180 degrees apart, and we can generalize this for all angles that are 180 degrees more than these as well. And written in radians, we can say that theta is equal to pi over 6 plus pi m. So at this point, it seems like we are done, right? Because we found out that when theta is equal to 90 or 270 or 180 degrees more than that, or this pi over 2 plus pi m, we did find out that's when cosine of theta is equal to 0. And we also found out that when theta is equal to 30 degrees or pi over 6, and every pi more than that or 180 degrees more than that, then that's when this root 3 times tangent of theta minus 1 is also equal to 0. Unfortunately, however, you need to do one more step to check for extraneous solutions here. It turns out that when theta is equal to pi over 2 plus pi n, that these are going to be extraneous solutions. Let me show you why. So while it's true that cosine of this pi over 2 plus pi more than that each time is always going to equal 0, it's not the case for tangent. Notice that at pi over 2, or 90 degrees, if we were going to take tangent of that, that's going to be tangent of theta. Remember, that is always going to be this opposite over adjacent, but we can't do that here. But tangent is always going to be y over x, right? And so we take a look at the y value here. The y value is going to be this 1. So that's going to be 1, and then the x value is going to be 0. So notice how that is going to be undefined because we can't divide by 0, right? And so that same thing is going to occur down here at 180 degrees past that at 270 degrees, where we're going to get this y value of negative 1. That's this y value, or the y coordinate, over the x coordinate of 0, and that's also going to be undefined. Right? So while this pi over 2 and 270 and so on and so forth does work for the cosine of theta equaling 0, it doesn't work for the tangent of theta. So if we did substitute these back into the original equation where we do have tangent of theta as part of it, we will get an undefined equation. Hopefully that makes sense why when you take a look at a tangent graph, there are asymptotes every pi over 2 plus another pi. And so for those reasons, the general solution for this equation is going to be theta is equal to pi over 6 radians plus pi m. And because I think that's still a little bit confusing sometimes, I'm going to go ahead and write out a few of these angle measures in degrees because these would represent the same thing as well for the first few. So hopefully you found this video helpful. Don't forget to check for extraneous solutions, And as always, keep up the great work, and I'll see you in the next one.